guys, now let's move to limits of the greatest integers function now. Since we now know what are greatest integers functions, since we now know how to graph the greatest integers function, so the remaining problems that we did not do under the graphing, you can just go and practice them. So let's look at problems involving limits of the greatest integer function. So we said consider the function f of x is equals to the greatest integer of x. This thing, remember, it is read the greatest integer of x. For the limit of f of x is equal to the greatest integer of x, as x approaches 0 from the left and from the right. Now, when x is approaching 0, for example, we have, this is our number line. This is 0. Let's say this is 1. Yeah, this side to be 1. Minus 1 now, and then it's positive 1. So now, if this is our number line, this is minus 1, and this is positive 1, right? If a particular value is approaching 0 from the left, that is to say, that value is close to 0, but it's coming from the left. So now that value could possibly be negative 1.99, for example, meaning it is very close to 0, but from the left. Now, also when a value is approaching 0, but from the right, it could possibly be 0.01, right? Very close to 0, but from the right-hand side of 0. So if that is the case, then let's try within our limit. If we take the left value, which is negative 1.99, now when the limit of the greatest integer function of x, as x approaches 0 from the left, which now let's assume that we don't know this minus 1. So now this could possibly be 1.99, right? So that could possibly be negative 1.99. So what is the greatest integer function of a negative number? Remember, we told you the greatest integer of a particular value x is that whole number or that integer, right, that is less than or equal to this number. And it should be the greatest of all integers that is less than or equal to this number. So if you look here, this is negative 1.9999, or let's say negative 1.99, right? Now, numbers that are less than this negative 1.99 are numbers in this direction. Let's assume we have something up here like this. So if this is 0, this is 1, this is 2, this is 3, for example, minus 1, minus 2, minus 3, and so forth, right? So now, if for instance this is negative 1.99, and for instance this is 0.01, so this is the number we're dealing with, right? All those numbers that are considered integers to this number, or that are less than this number also, they are in these directions. So amongst all of these numbers, find the greatest of all of these integers. So you have 1, you have negative 2, you have 3, you have 4, and so forth. Minus 1 is greater than all of these integers. Therefore, the greatest integer of negative 1.99 is just equals to minus 1. So this just equals to minus 1. What if you have the limit as x approaches 0 from the right is given by the limit of greatest integer function of x as x approaches 0 from the right hand side? So let's assume we have a value approaching 0. There's 0 from the center here. a value approaching 0 from the right hand side, which could be 0.01. So if we replace this thing with, if we replace this x now with 0.01, for example, what will we have? So this is 0.01. So we want to consider all of those integers that are less than 0.01. So less than 0.01 are the integers on the left. So when we're looking at those integers, we consider 0, minus 1, minus 2, minus 3, and so forth, right? So because 0 is the greatest of all of these integers, we say we take 0. So that's the reason why the limit of the greatest integer function of x, or the greatest integer of x, for example, as x approaches 0 from the left, is just equal to minus 1. Then, when it is approaching 0 from the right, it's just equal to 0. Generally, we can now conclude that since when it is approaching 0 from the right is equal to 0 itself, we say the limit of the greatest integer of x as x approaches some value n from the right is just equal to that value n. But notice that if it is approaching some value n, okay, assuming this is x, right? It is approaching 0 from the left. So you notice that if we subtract 1 from in this 0, meaning you have like 0 minus 1, you will have negative 1, right? So let's assume now this 0 now representing n. So in all cases now you will be subtracting 1 from within the value when it is approaching it from the left. So that's why we got the limit of the greatest integer of x as x approaches n from the left is just equals to n minus 1. Let's do the first example. The first example says the limit of the greatest integer of x as x approaches 3 from the right. Since it is coming from the right, the answer will just be equals to 3. Now let's continue. So question 2 says the limit of the greatest integer of x as x now approaches 4 from the left. So since it is approaching a particular value 4, which represents n from the left, is just equal to n minus 1. And our n now is 4 minus 1, and just equals to positive 3. Likewise, the limit of the greatest integer function of x minus 1 as x approaches 3 from the left is just equals, now wherever we see x, we should be able to put 3 minus 1 minus 1. So this now will just give us 3 minus 1 is positive 2. 2 minus 1 is positive 1. Number 4, the greatest integer of the limit of x plus the greatest integer of x as x approaches 4. So for this case, remember, we do not apply this greatest integer property on this x because this x has no greatest integer symbol. So we only apply it on this one. So we have 4 plus, now the greatest integer function of, that's the greatest integer of x as x approaching a particular value from the right is just equal to that value. So it's 4 now plus 4, which is 8. Now, the greatest integer of x squared as x approaches 2 from the right is just equals to 2 squared, which is now 4. Now let's look at question 6 to 10. Question 6 says the limit of x plus 2, the greatest integer of x as x approaches minus 3 from the left. So we apply the limit. Now remember, now the first x has no greatest integer symbol. So we're just going to write minus 3 plus 2 times. Now in the second area, now we have the greatest integer symbol. So this is the greatest integer of x. So when x is approaching a number from the left, which is like in this form, it's just equal to that number minus 1. So this is now minus 3. Now minus 3 minus 1 is minus 4. So it's 2 times minus 4. Right? So 2 times minus 4 now is minus 8. So minus 8 minus 3 is minus 11. So the second case, you have the limit of the greatest integer of x plus 2. X approaches 2 from the right. So this one is just 2 plus 2 is equals to 4. So this one now we apply the limit. You have 10. So you can now apply the limit on the first x because it does not have any greatest integer symbol. So it is what is inside now we apply the property to. So the greatest integer of x as x approaches 10 from the left is just equals to 10 minus 1. Now we do not write this greatest integer symbol any longer. So 10 minus 1 is 9, and then 10 times 1 is 10. And move to question 9. Now you have this one to be what? 8 minus 8 plus the greatest integer of x is 8 plus 1. So this is now 0 plus 9 is just equals to 9. So quickly we'll do the last one. So for the numerator now you have the square root of minus 5 minus 1 because it is approaching minus 5 from the left. So we subtract 1 from within minus 5. So this is now x squared. The first one is this x squared minus 7. Divided by x is just minus 5 plus 2 over 3. 2 over 3, this is 3. Times 2 minus x now is minus 5 minus 1. Because the difference between this x and this one has no greatest integer symbol, but this one has a greatest integer symbol. So we must minus 1 from within the 5 that we're putting right here. So we enclose this whole thing with a bracket because we already have a parenthesis within. So in the numerator now, minus 5 minus 1 is minus 6. So it's minus 6 all squared minus 7. Then you have minus 5 plus 2 over 3 times. Now minus 5 minus 1 is minus 6. Negative times negative is positive. So it's 2 plus 6. Now negative 6 times negative 6 is positive 36. 36 minus 7. Down here you have minus 5 plus 2 plus 6 is 8. 8 times 2 is 16 over 3. So 36 minus 7 will give us 29. The square root of 29 all over 3 times 5 is 15, negative 15 plus 16. It just equals to positive 1 over 3. So for this now, we can see the root of 29 divide 1 over 3. And then we can rewrite this first fraction, which is like 29 over 1, the root of 29 over 1. And then we reciprocate the second one. So it will give us 3 over 1. We change this to multiplication. So therefore we can have the root of 29 and then we have our 3 outside. So it's 3 the square root of 29.